So the final part of Pythagoras is the converse of Pythagoras' theorem. So the converse of Pythagoras' theorem is used to determine if an angle in a triangle is right-angled or not. And remember that the right angle is always opposite the hypotenuse, which is the long side of our triangle when we're trying to do our proving. So the theorem that we've encountered so far is that if triangle ABC is right-angled at C, then C squared equals A squared plus B squared. The converse says that if C squared equals A squared plus B squared, then our triangle ABC is right-angled at C. So the process that we need to go through to prove a triangle and that gives us our A squared plus B squared. Then we're going to square the longer side. That gives us our C squared. And then we're going to compare those two answers to each other. If they're equal, then we can state by the converse of Pythagoras that the triangle is a right-angled triangle. If they're not equal, then we can state by the converse of Pythagoras that the triangle is not a right-angled triangle. And we may have to look at the properties of shapes if it's asking us to prove that a shape is a rectangle, because we know that the four angles in a rectangle are all right angled. So if we look at the diagonal of that rectangle, we can then prove whether or not there is a right angled triangle in that shape. So the first example, it says, show that triangle PQR is right angled. And for part B, we're going to name the right angle. Now, show is a bit like prove, and you need to use maths in order to do that. So the first thing we need to do is we need to work out which ones are the short sides and which one is the long side. So we can see on our diagram of triangle PQR, the short sides are the 1.5 centimeters and the 3.6 centimeters, and our long side is the 3.9 centimeters, side PR. So the first thing we're going to do is we're going to square the shorter sides. So if we say that we want PQ squared, and PQ squared is going to be 3.6 squared, which is 12.96. We then want QR squared, and it's 1.5 squared, and that gives us 2.25. Then we want to add them together. So we want to calculate what PQ squared plus QR squared is. And that's going to be 12.6 plus 2.25. And that's going to give us a total of 15.25. Then we want to work out what PR squared is. So PR squared equals our 3.9 squared. And that's going to give us 15.25. So now we need to compare our answers. So we can do it using the numerical values, or we can do it using our expression. But what we want to say is that PQ squared plus QR squared equals PR squared, or we want to say that 15.25 equals 15.25. And so we can see that the values are equal, so then we need to explicitly state that by the converse of Pythagoras, triangle PQR is a right-angled triangle, and I'm going to use the abbreviation RAT there. Then don't forget to answer part B, because part B asked us name the right angle. Now you know that naming angles, the letter that is at the angle goes in the center. And so we've got angle PQR QR, or if you want to, you can call it angle RQP is the right angle. So our final example is looking at triangle ABC. Now, triangle ABC represents a flower bed in Mr. Square's garden, and every flower bed must have at least one right angle. Will he be happy with this one? So it's asking us to determine whether or not it's a right angled triangle or not. And so we know that we are going to have to use the Converse of Pythagoras. So I've got the process up at the side there. But the first thing we need to do is we need to determine which ones are the short sides. And we can see that the short sides in this triangle are AC, which is 2.9, and BC, which is 4.1. And our long side is AB, which is 5.2. So we want to square the shorter sides and add them together. So we've got AC squared plus BC squared. And that's going to equal 2.9 squared plus 4.1 squared. And that gives us a total of 25.22. Now we need to square the long side. So our long side is AB. And AB squared is 5.2 squared, and that gives us a value of 27.04. So you can see that this time AC squared plus BC squared does not equal, so we're crossing through our equal sign, AB squared, or you can compare the numerical values. 25.22 does not equal 27.04. So because they're not equal, we know that it is not a right angled triangle. So we need to state, so by the converse of Pythagoras, angle C is not 90 degrees. So triangle ABC is not a right angled triangle. Now, make sure you answer the question, because the question actually asked if Mr. Square was going to be happy with this flower bed. So we need to state, therefore, Mr. Square will not be happy with this flower bed. So in summary, for the converse of Pythagoras, where C is the longest side, if a triangle is a right angled triangle, C squared equals A squared plus B squared. And so if C squared equals A squared plus B squared, then the triangle is right angled. If the triangle is not right angled, then we can't use the converse of Pythagoras to work out missing sides. And so therefore, C squared is not equal to A squared plus B squared. We know that the triangle is not a right angled triangle.